All right, today we are doing lesson 22, problems about perimeter and area. So let's solve some situations that involve perimeter and area. Quick reminder, situation is another word for story, eyes on me. Could be another word for story. Remember we had to write a situation yesterday. Think of that as story. Second reminder, perimeter is when we add the length around an object. Area is the amount of space inside of it, and we multiply. Okay, you guys remember? Okay. All right, how many do you see? Page 102. I already forgot. Maya just told me. Okay. Nope. Why are our hands up? Guys, you shouldn't have even started yet. Okay. How many shaded squares do you see and how do you see them? Answer both of those questions. Write notes on your paper. Charlie, where are you off to? Not even back. All right, first of all, how many shaded squares do you see? I want to know how many you see. Hadley. 27. How many do you see, Emma?
I see 27 too.
Okay. How do you see them? Riker, how do you see them?
They're blue, not white.
Okay, so you see blue. Okay, Brooke?
I see them in a group of 10, 9, and 8.
Will you come point those out for me? And I'll draw it on here.
Because this is a group of 9. This is 1, 2, 3, 4, 5, 6, 7, 8.
So
9.
kind of this 3 by 3. Oops.
Yeah, and then this is 8. Right here.
Oh, over here is 8.
And then this is 10.
And then did you just add those up?
Yeah.
Did anybody else see it like that? That's how I saw it too.
Then you could also do it across.
Wait. Somebody else might want to share that idea. Okay, this is how Brooks sees it. Does somebody see it in a different way? All right, Kara, come on up. How do you see it? I'll erase this one. Brooks was ready to tell us all of the different possibilities, weren't you? Okay, Kara, how do you see it?
How I see it is, that's 4.
Okay, so you see like a 2 by 2 right here?
Yeah.
Okay.
And I saw also an 8 here.
Oh, okay, so you also saw the 8. Okay.
And I saw 15 in the middle.
Oh, a 5 by 3, which is 15. Very nice. Did anybody else see it that way, the same as Kara? Okay, cool. One more. All right, let's see. All right, Hadley, come on up.
I see them in all groups of 3.
Okay, so show me.
So like, there's 3 here, and then I would see 3 here, and then like other 3s in all groups.
Oh.
I counted by 2s.
I struggle to see that, but yes, I believe you. So you kind of saw like staircases?
Yeah, kind of.
Like that?
Mhm.
Like Tetris.
Yeah.
Okay. All right. Are there ways, look at this, are there ways to partition that are more helpful than others? And Hadley, I'm not picking on you by any means. Which ways are the most helpful, do you think? Cave.
Probably the 9, 10, and
So kind of for you, when they were like in bigger chunks.
Yeah.
Yeah, bigger chunks. Okay, I can see that, Coral.
I feel like the 4, 15, and 8 make more sense to me.
I have to say I did not think of that, and then when Kara came up here, it made sense to me. So thank you. Okay, when you guys are partitioning, you might notice that some are more helpful than others, but also there's more than one way to do it, right? So we're really thinking in a Tetris-y way. I like that term. All right, mark your spot in your book and close it. We're going to launch. Actually, I don't know if it's a launch because it's the active. Keep your book shut. Shut your book. I want your attention up here. Okay, Jada's teacher bought a poster paper that measures 36 inches by 24 inches. Her plan is to cut it into pieces, rearrange them, and tape them back together. What is she, bored? Okay, anyway. Oh, to create a welcome banner that is 8 inches tall and 8 feet long. I was like, who has time to do that? Kind of what I was doing last night. I was making Bradley a giant Paw Patrol badge for his party. And when I printed it, it was on 9 different pieces of paper. And I had to cut it, line them up, rearrange them. Yes, it was exactly like that. So I felt very experienced. I was like, I know how to do this. But anyway, here's the whole point of this. So the poster is 36 by 24. It's drawn up here. She's going to cut it up and rearrange it, but she wants it only 8 inches tall, but 8 feet long. Does she have enough paper to make the banner? Show your reasoning. How many square inches is the poster paper? You're going to work with your partner and then we'll discuss. And that's the only question. So, okay, so there's 2 parts. Well, there's several parts to this question, but we're going to start with number 2. I know that seems backwards, but we need to know the answer to number 2 in order to solve number 1. So for number 2, it says how many square inches is the poster paper? So how many square inches? Raise your hand. What did you get? Okay. Gage, what'd you get?
I said
No, my question was how many square inches?
The second question.
Question 2. Stay with me. Delaney. 864. Raise your hand if you got 864 square inches. Okay, so let's look at how we would get that. Guys, remember, anytime we're finding area, we're going to do length times width to get area. So we had to do 36 times 24. If I was to do 36 times 24, I would break it into 36, 24, if I was going to do the box. 2 times 3 is 6 plus 2 zeros. 2 times 6 is 12 plus a 0. 4 times 3 is 12 plus a 0. And 4 times 6 is?
24.
Good, 24. So then I'm going to quickly add those up. 600, 120. Oh, we have 120 twice, don't we? And 24. Running out of room. So that would be 4, 6, and 8. 864. Okay? So if you made a mistake, correct it. So we know the original paper, the original poster, was 864 square inches. Now we're going to look at number 1. Does she have enough paper? So So she wants her banner to be 8 inches tall and 8 feet long. What is our next step? Quinn and Aaron, let's pay attention. What's our next step? I don't want an answer. I want to know my next step. Okay, Gage. 8 times 12. There's no 12 on here. Why would I do 8 times 12? Can you explain why? Because the inches? The inches. What about them? How many inches are in a foot? Why? Why do I need to know that?
Because it says inches and the bottom.
Look at. So we found square inches, right? And then here we know 8 inches tall, but 8 feet. Guys, we have to change those feet into inches. So we would have to do like a little helper problem. Everybody, what is 8 times 12?
96.
So that would be 96 inches. So instead of 8 feet, I could think of it as 96 inches. What is my next step, Hadley?
96.
So if I do 96 times 8, I will find the area of the welcome banner, right? So do it with me. 8 times 6 is?
48.
Put the 8 down, carry the 4. 8 times 9
72.
plus 4.
76.
So I know the welcome banner will have an area of 768 square inches. Does she have enough paper? And you have to tell me how you know. Okay, Riker.
No, because if you like converted a feet, you still need 8. I don't need it.
Okay, Jace.
Yes, because you would take the answer you got from 96 times 8 and subtract it from 864.
She's going to have too much paper, so she's going to throw some paper away. So if I take the size of this big poster, which was 864, and I subtract how much the welcome banner will be, I'm going to have some left over, aren't I? So yes, she does have enough. Does that make sense?
Yes.
Why are you saying no, Gage? She's starting with this big chunk. And then she wants it to be 8 inches tall and 8 feet long. The area of that would be 768. 768 is less than 864. Okay, Brooks.
Could you just do 864 minus 96 to find out? Because then there'd be 8 feet minus, and then it'd be 8 feet minus your area, and then you would have, and then if it was more than 8, you know you had it right
I don't know.
there. Okay.
That's not a good answer, is it? I feel like you have to find the whole area.
Okay.
I'm not sure. I would have to measure it out and try your method.
Because, I
feel like-
subtracted it and I got 768.
Yeah. Oh, you subtracted 96?
Yeah.
Oh, so then you knew you had enough.
Yeah.
Yes.
Okay.
That makes sense now. Okay. Brooks, you're making me think about this problem in different ways. My head hurts now. Thank you. I think I just got a few new brain cells. Thank you. Love it. Okay. We just looked at another strategy. Thank you, Brooks. Okay. So, mark your spot. This is our launch. Okay. Activity 1 was setting you up for activity 2. Here we go. A classroom is getting new carpet and baseboards. Do you guys know what baseboards are?
Yeah.
What are they? Raise your hand. I don't know if I would have known as a 4th grader, but maybe. Jerica, what are baseboards? And here it's gray. Do you guys see? And it's actually rubber. At my house, they're wood. Are they wood at your house?
Yeah.
And when I was little, my mom would make me scrub them.
Oh, too.
And it was like punishment. I hate cleaning baseboards. Gate.
Yesterday we got a new rug, and I had to clean them.
You had to clean the baseboards. Yeah, it's such a pain, but it really does look better once you clean them. Okay, so they're getting new carpet and baseboards. Tyler and a couple of friends are helping to take measurements. I don't know if the district will let you guys help, but maybe. Here is a sketch of the classroom and the measurements they recorded. So I see this part of the room is 8 feet. It's not a rectangular room, is it? I guess it could be like 8 feet, 3 feet. It could be, maybe they have a cabinet there. 3 yards, then 4 yards. 204 inches, 108 inches. Tyler and his friends should have agreed on one measurement, right? But they've got feet, yards, and inches. That is what I noticed. What do you notice? What do you wonder? Coral. Oh yeah, why do they need new carpet?
And also, I also wonder why do they have to put it in different measurements?
Maybe there's a reason for the yards and feet and inches. Kira, what are you thinking? Yeah. I don't know. I don't know why. Aaron.
I wonder why their classroom is so short.
Yeah.
Our classroom is not 180 inches. That's probably longer than 180.
Yeah.
That's like
Yeah.
4 feet. That's like what's that?
Okay. So, I think we understand the predicament. For each question, show your reasoning. You're going to work with your math partner. How many feet? Is this a key word right here? That's a star. Didn't look like a star. How many feet of baseboard will they need to replace in the classroom? So that's going to be perimeter, right? So this would all be baseboard. How long is my purple line? How many inches is that? Are you going to have to convert?
Yeah.
Okay. 1,200 inches of baseboard material was delivered. Is that enough? How many square feet of carpet will be needed to cover the floor area? Area equals length times width. Okay. How many inches are in a foot?
12.
12 inches in 1 foot. How many inches are in 1 yard? 36. What else do we need? Oh, how many feet are in 1 yard? 3. Okay. And 0. Waiting. Okay, guys, your cool down is going to take you a little bit, so I want to make sure you have time to do it. First of all, how many feet of baseboard are they going to need to replace? How many inches is that? Bless you. Okay, so first of all, tell me how many feet they need to replace. Okay, Cade, what'd you guys get?
We got 55
55 feet? You're close. Madeline? Raise your hand if you got 64. It is 64 feet. So check your arithmetic. Who figured out how many inches 64 feet is? How many inches, Charlie? Okay. We'd have to do 64 times 12. Chase.
647.
Raise your hand if you got 647. Sounds right. 8, 12. Oh, no. You were close. It should be 768. Check your math. Is that what you got, Cade? Were you doing it with me? 768 inches. Okay. So 1,200 inches of baseboard was delivered. Everybody, is that enough?
Yes.
Yes, because they only need 768. Testing.
I thought this would be the way that we're doing because I finished it.
Just keep it tucked into your book for now, okay? Okay. Number 3 is like a bonus question. Did anybody find an answer? How many square has to be in feet of carpet would they need? Let's hear a few answers. Jace, what'd you get?
I got 64.
Square feet? Yeah, that doesn't sound right. Gauge. Okay. Braden?
Can I show you how I did it too?
I just want the answer because we're going to run out of time.
I got 255 square feet.
255 square feet. Is that what you got, Riker? Okay. I don't know the exact answer, but it does sound reasonable.
How we got it?
Hold your thought. So, do you guys remember, everybody, pencils down, look up here. Okay? I don't know if they're right, but I might figure it out while you do your cool down to see. But, do you remember how we sectioned off in our warm-up? Do you remember sectioning it off? And we were counting? So that's kind of what you have to do with this. This one's bigger, so we'll look at that. So basically, you would have to look at it and say, okay, if I draw a line right here, for example, I know this side is 8 feet. This side is 180 inches. This side is 3 feet plus 4 yards. And this side is 204 inches minus 8 feet. And then you could find the area of this one. That is one way to do it. We're going to run out of time. Put your hands down. Guys, listen. Okay? I would love to spend more time on this problem. And maybe we will if we have random extra time. It is definitely a challenge to figure out this area. And the reason it is so challenging has to do with the fact that, well, first of all, the last time I taught this is when I taught 6th grade math. So I really feel like this might be 5th or 6th grade math. So here's your challenge problem today, right? Okay, perimeter, we add the length. Area, you multiply length times width. Okay. Let's go get out your cool down. When you're done with your cool down, you're going to put it on my desk.